Hello everyone, I'm Dr. Rajesh and today I am with you with my new video lecture, and this is on the topic time of flight, horizontal range and greatest height of a projectile. And these are two my companions for the lecture, and they are really very happy in this particular topic and they feel that this topic is very easy. So let us see, and really this topic, believe me, is very easy. Now firstly we will study time of flight. Time of flight is the time taken by the projectile during its flight. So definition of time of flight can be given as: it is the total time for which the projectile remains in the air. So the from the point of projection till it reaches the ground again. So that total time taken by the projectile to travel that distance is called its time of flight. Like you take the figure, this one, and say this point is O and this point is say A and this point is B on the ground. So the time of flight is from this O to B. This time taken by the projectile is called its time of flight. And we know that from the motion of projectile we know two formulae, and we have derived in the very first lecture on the projectile: x is equal to u cos alpha t, because the horizontal component of velocity always remains the constant throughout its motion. Say this is the initial velocity direction u, this is angle alpha, it has components u cos alpha, vertical component u sin alpha. So this component, as horizontal acceleration is 0 during the motion, we have already studied, so this component always remains the constant during its motion. So the horizontal distance traveled in time t is equal to velocity into time is distance. While we also studied the vertical, it is y is equal to u sin alpha t minus 1 by dt square. These articles we have already dealt in with details. So if I say that at point O, at point vertical distance is 0, fine, and time taken is say t, which is time of flight, then from 2 it becomes 0 u sin alpha capital T minus 1 by g t square. This further implies that 0 t is common, u sin alpha minus 1 by 2 g t. This implies that either t is equal to 0 or u sin alpha minus 1 by 2 g t is equal to 0. So this further implies that t is equal to 0 implies point O, which is not required point. Therefore u sin alpha minus 1 by 2 gt is equal to 0 implies u sin alpha is equal to 1 by 2 gt. This implies that 2 u sin alpha by g is equal to t. So this is the formula for time of flight. Time of flight. Now next we find the horizontal range, and number 2 point, horizontal range. Say it is denoted by r. So this distance O to r is called horizontal range, and it is denoted by r, and its definition is given by 1. Range of horizontal distance is called horizontal range. Range means the distance this traveled horizontally is called its range and denoted by r. That is the distance between the point of projection O and point it hit the ground. It hits the ground, like trajectory of a kicked ball by a footballer. Okay, so this it hits the ground. So this horizontal distance is called horizontal range, and we know the formula for horizontal distance is given by equation number 1. So this formula will be used, okay, by equation number 1. So we can write that we know that x is equal to u cos alpha t, and when it hits the ground, when it hits the ground at B, their time is time of flight. Time taken by the projectile to reach at B is the time of flight. We have already derived this expression. Then this above equation will become u cos alpha dot t, and we have derived the expression for time of flight is 2u sin alpha by g. You can see this is the expression for time of flight, and we have used here. So this 2 cos alpha sin alpha is sin 2 alpha. So this can be written as u square 2 sin alpha cos alpha by g is equal to u square sin 2 alpha by g, implies r, which is horizontal range, is equal to u square sin 2 alpha by g, and you may name it as equation number 4, and this may be named as equation number 3. So we will see this is the horizontal range, and this horizontal range is maximum, r is maximum if sin 2 alpha has its maximum value, which is 1, and sin is 1 when angle is pi by 2, that is alpha is equal to pi by 4. Therefore r is maximum when angle of projection is pi by 4, and that maximum range is given by r max is given by u square sin pi by 2, because we have replaced here pi by 4, twice will cancel, it will be pi by 2, divided by g is equal to u square by g. So r max is equal to u square by g. So this is the maximum horizontal range. Maximum horizontal range. Fine. So next we are required to find greatest height of a projectile. Greatest height of a projectile, and it is defined as the maximum height achieved by the projectile during its motion. This is the definition. It is the maximum height achieved by projectile during its motion. So we are studying the third point. Third point is greatest height. So it is the maximum height achieved by the projectile during its motion. So if we again go back to the figure, if we go back to this particular figure, this height, if I say, is the maximum height achieved, and this is h, and at this particular point we have tangent, something like tangent will become parallel to horizontal, and if I say alpha will become 0. So horizontal component of velocity is u cos alpha is equal to u. Fine. And the vertical component of velocity is u sin alpha is equal to u sin 0 is equal to 0. So therefore if I say that at the maximum height vertical component of the velocity will become 0, so I can infer from here the vertical component of the velocity will become 0 at the maximum height. So this is I'm going to write at maximum height the vertical component of velocity becomes 0. So here I have plotted the figure again. This is the velocity u and this is horizontal component at initial point. Vertical component is u sin alpha, and at greatest height this vertical component is 0. So we know a relation v square minus u square is equal to 2gs. V square is equal to u square plus 2gs. V is the velocity, say, at point A, vertical component of the velocity, and vertical component of the velocity at point A is 0. And u is the vertical component of the velocity at initial point O. So this will be u sin alpha. Vertical component is being taken because we are dealing with the height, and since the motion is against the gravity, so this is minus g, and at point A s is h. At point A s is equal to h. V is velocity, vertical component of velocity at point A, which is 0, and u is initial vertical component of the velocity. So this implies that u square sin square alpha minus 2gh is equal to 0. This implies that 2gh is equal to u square sin square alpha. This implies that h is equal to u square sin square alpha by 2g. So this is the formula for greatest height of the projectile. So in this article we have discussed the time of flight, horizontal range, and greatest height. So in this article we have discussed three parameters of the projectile: time of flight, horizontal range, and the greatest height. Time of flight, horizontal range, greatest height. So this is very important article from the examination point of view, and very easy. So this is all I have from this lecture, and if you have liked the video, please like, subscribe, share, and comment. So this is Dr. Rajesh saying you goodbye. Thank you for watching and take care. Bye bye.